Measurements, volumes and surface areas. There will be one like this in the November exam. There will be more than that in your next test because we're testing on a lot of things in one sum. So when it's only about 2 or 3 topics, then we do very good investigation whether you can do it or not. So one of them in an exam, but there can be more than one of them in your tests. So the question says, this is a water tank. A cylindrical water tank, does that make sense? Because this is a cylinder with some sort of a coverage on it that looks like a cone. And now this is where it comes in that you've got to combine in stuff. So I could, for instance, say, let's put some cement balls in there and put them at the bottom, and I'm putting in 10 of them, and how much less volume would there be? So you work out the volume of the cylinder, then you'll put some balls, it's not the sum, I'm just thinking some other stuff out. Put some of these big cement balls in there, because I want the water to rise a little bit, so how much volume will there now be, whatever. So if there's 10 balls in there, I'll have to work out these balls, and I'll have to tell you their dimensions. That the radius was 50 centimeter, big cement balls that's going to go in there. Please sit still. So that if I go and work out those volumes and I put them inside of there, and I've got the total volume of the cylinder, how will I know how much water is in there? So you've got to take those 10 balls, whatever the total was, and subtract it from the total of the water inside if it's filled up or whatever the case may be. You with me? So we can combine them, and it's the cone, and it's the cylinder, and. Okay. So first of all, this question said that this cone there at the top has that the cylinder has a radius of 0.5. But that implies that it's also the radius of that cone there at the top because it's fitted exactly. And don't get too technical, but ma'am, it's got to go a little bit over what, okay? We don't assume anything, you're not engineers trying to build some stuff. We say it's the same, it fits on top of each other. So that would be the radius for the cylinder and the radius for the cone as well. Then they also told me something funky, that the perpendicular height there makes an angle of 35.5 with the perpendicular height and the slant height. So I don't know the slant height, right? They give me a whole bunch of formulas like I told you to expect. And they weren't supposed to give you these ones, because that's the volume and surface area of a cylinder. Are you with me? But they did. This was actually 2016, the final exam, grade 11 final paper, coming from the district. This comes out of it. Okay, so they did give it to you. So sometimes you're lucky and sometimes you're not, but I have to give you the stuff for the cones and for the spheres. I have to. That's law. So if they're asking me to work out AB, which I didn't put on here, how would you do that?
Use tab.
Okay, so you've got to go for your trig, right? That's why this is in paper 2. But it can just as well be in paper 1 as well. So for AB then, she wants to use tan, is she correct?
Yes.
Working with that angle there, and I'm trying to find the height, then this would be the adjacent and opposite, because this is the hypotenuse side, which is the slant side. Okay, so for that, I know that tan of 35.5 would be the same as 0.5 over the AB that I was looking for. That's one method. How about the sin rule? Okay, if you got this angle, you could. Some of the angles of a triangle. If you've got it, you can work with that pair, and you have another pair. And will your answer be the same?
Yes.
Yes. Okay, alternatives. For this answer then, what would AB then be? You don't need to write me that step, but how do I get to that AB?
0.7.
0, 0,
Then do it divide or times?
that one goes there, that one goes, oh, I wrote it wrong. Is the answer 0.7 if you divide?
Yes.
I wrote it wrong. Okay, if I take the AB there, then this one swaps places over there, I'm sorry. So it was tan 35.5 divided. So So the answer is?
0.7.
Okay, now how many digits? Always. Even if they start off with 0, just one digit 5, you always stick to 2 decimals unless specifically said in the question. So it's 0.7?
0.
Is it 0?
Yes.
Okay, now if they didn't say anything, that's what you were supposed to say. Can you see this big water tank with a 1/2 meter diameter? So this is about the size of the tank. The height of the tank is just about a little bit taller than what I am. Do you see this little tank, Jojo tank there, with this little bit on it? So that you must figure, they're going to ask you now, how much water does this take? And you get 2 liters. Then you must think, what?
Doesn't make sense.
Doesn't make sense. Are you with me? Get yourself into the picture here. Now the second part of the question says, if water is, let me rather read it because I'm going to forget all the words. When the tank is full, there's an electric pump that switches on. What has this got to do with everything? Are you with me? It's a different scenario. If this is full, where is full?
It's
Volume is.
Are you with me here? The volume of the cylinder. Because how can it go in there at the top? It's going to overflow and whatever. So that's where it's full. That's just the lid. If it's full, then the tank switches on, the pump switches on and starts pumping the water from this thing, typically like a Jojo tank. You want to water your flowers, and it starts pumping into the irrigation system. They want to use it for something, for watering, at a rate of 0.52 square meters per hour. Square meters, isn't it supposed to be volume?
surface area.
Okay, but now you are spreading surface area around your garden. So that's where the 0.52 square meters per hour is going to go out to. But the pump automatically switches off when the tank is quarter full. So it doesn't go all the way, and now you are looking for drinking water and everything's on the plants. So it's going to come pumping out until it's quarter full. So first things first, because the question was, how much time would it take to feed into the irrigation system? How much time would it take? I'm sure that is wrong. That this should have been cubic. It is so that it's a flat surface, which is going to be square meters, but that volume of water will have to pump out. You see it was written there with a square, but it can't work that way. The pumping out is going to be of the volume of water, and the volume of water is going to be a certain volume that's pumping out per hour. It has to be a 3. Okay. So first of all, before you start anything else, what must you work out? How will I know how much time it's going to take? You've got to get the volume of the cylinder. Well, a cylinder, we can't do it that way. The volume of the cylinder would then be
Square.
okay, which they've given to you, the kind, and you know that the radius is 0.5 and the height was 1.8. That's the easiest part. This question just counted 4 marks. Way too few marks. Way too few marks. But that was only like one of the marks.
Isn't it less than 1.8?
Because
that's
of
the
the-
total.
No, they said the cylinder. Wait. I'm sorry. Did you read it? I must read again. It with the program. And yes, I wrote it down wrong. I wrote it here. They actually said 1.8 over
For
here.
the whole thing.
Oh, thank you for seeing that.
Special.
Okay, if that was the question, then this is where the water would stop. It's not. So the child that wrote this is going to get no more marks. 1.8. Now you'll be penalized, and then we'll carry on. CA marking. So how much is the height there?
1.1.
1.8 minus the
0.7.
0.7, which gives you
1.1.
1, which would be a mark. Are you with me? So that total there was what, 0.7, and now you also know that this is 1, 1.1 and 0.7 gives me the total up to the top of the tank, which gives me an answer, please, of
0.86.
okay. Give me more, please, because we still have to carry on with this answer.
394.
What? out, dot, dot, dot. Are you with me? Don't touch your calculator, let it stay there. Don't round off, because you're still going to do something with that. Now that's not the end of the sum. I think this was originally in 2016, a long time ago. It was right about just 1 mark or maybe 2, I can't remember. But then the last part of the question says, if the rate of water flow is 0.52 meters cubed per hour, how long will it take to water until this thing is quarter full? Because it keeps on pumping until it's quarter full. So how much water has to pump out?
Won't you?
All of it.
We divide water.
3/4. I'm glad to hear that. Not just a quarter. You pump out until there's a quarter left. But what are you pumping out? 3/4 of, which you haven't touched your calculator on, which would be how much, please? So take that answer that's there, times with 3 and divide by 4, or times by 3/4. Same thing.
0.64795.
Are you with me? That's still inside of the tank when it's left. Or is it? That's gone. That's the pump out. In is the difference between the two that's going to stay there. But now that's still not the answer. Tricky, right? They want to know how long this will take to pump this out. So the time to pump out, how do I work that out? Because they told me that in 1 hour, it would be 0.5 cubic meters that will be pumping out in 1 hour. So how will I know how long it took for this to pump out? Divide by 0.52. And that is going to not give me an answer in cubic meters. That's going to give me an answer in hours. Because this was cubic meters, this is cubic meters per hour, so the answer will be in hours. Can somebody please give me that answer divided by 0.52? 1.27. 246, so that's going to be 25. What's man going to do? Now I'm rounding off because that's the final answer. How long will it take for me to pump out this water? And that would be 1 hour, 25 minutes.
No, 15 minutes.
Okay, remember please that 1.25 hours is 2.25 or a quarter of an hour, which is 15 minutes. They never asked that because that could be worth another mark. But that's not 25 minutes, right? If I say 1.5 hours, what does it mean? An hour and 30 minutes. 1.25 hours is not 1 hour and 25 minutes. It's 0.25 of an hour, 0.25 of 60 minutes, which will still give you 15. Okay, and sometimes it can be 1.23. You can't say it's 23 minutes, just realize that, for in case they sometimes ask you that. So, I'm going to give you one more for homework. It's typical, similar to this. But we are joining cylinders and cones and balls and all sorts of interesting stuff to work out answers like this. And we do use some sin, cos and tan. Sin, cos and tan rules, even the cos rule. And that's why I'm going to give you a test which includes the trigonometric methods of working out sides and angles as well.